Okay. Can you hear me? Yes, does it work? Brilliant. Let's go. So hello, everybody. Today we're going to talk about running production logs safely, hopefully, using Tessera. It's actually quite fun to give this talk after Andrew's talk this morning. We'll try to explain how we try to solve some of these issues that he raised. My name is Philip. I'm an engineer at Google in the TrustFabric team, working mainly on certificate transparency these days.
And I'm Roger, so I don't have to introduce myself again. So we can go straight to what is Tessera. So there was an introduction talk last year. We are here to present, but this is the work of the entire team and collaboration with great ecosystem participants and some of whom who are in this room. Tessera is a library to build tile-based transparency log, and it is open source. It is GA already. It is written in Go, and the philosophy is simplicity, resilient, and available, flexible but opinionated. So Tessera will always put you on the safe default path, but you can tweak the configuration if you want. And for APIs, write is actually very simple. Just need to append.add to add your data. And then for read, we comply with the C2XP T-log tile spec. C2XP is the community cryptographic specification project. It's open source. It's maintained on GitHub with standardized logs, read API for with file-like structure. Especially for the T-log tile spec.
And we know that you all run different type of infrastructure, so it was very important for us to make it such that Tessera can run on as many platforms as we could support. So if you use POSIX and have just regular servers, you can run Tessera. It also works natively on GCP, AWS, using specific products such as GCS and Spanner. Or you can just run it yourself with any S3 compliant storage system and a MySQL database. In terms of performance, it can scale quite well from 1 QPS or even less if you want to more than 15K QPS. How far it can go really depends on the infrastructure that you have, but also how much money you're willing to spend because, well, you know, if you use the cloud, for instance, the more QPS you want to serve, sometimes you have to pay more money. It is being used. It is being used in production by Sigstore, and then its CT version, which we call TesseraCT, is used in production by our friends at IPNG, and we use it ourselves and staging at Google, and I hear that there are more log operators that have starting to deploy it in production, so that's exciting. It was very important for us to make it reliable, and so as such, you can run multiple servers for a single log if you want. If you want to run only one server, you can as well. If you want to run 0 server, you can use some serverless type of deployments. Should work. Actually, we've tried it, and it works. So now that we know what Tessera is, we're going to look at some challenges that are inherent to running transparency logs, CT logs, but also any transparent logs, and we'll see how Tessera tries to address them. The first one is that outages happen, computers go down. So you run your Tessera server, and then it can just go down. If it goes down, it means that you can have some availability issues, indeed. So one of our goals was to make sure that the right endpoints would stay available as much as possible, and that also you could run multiple servers in one go, which could be either intentional, because you actually want to have 2 servers, or because you configure your system to have only 1 server, but the cloud environment that you work on make it such that at some point you have an update and there are 2 running for like half a second. So Tessera's approach for this is to only use atomic operations. And that means that 2 servers cannot update the log at the same time. It's just not possible. Depending on which backend you use, we have slightly different implementations. So we can say that we have 2 main categories of implementations. The AWS, GCP, and S3 and MySQL one, they use databases that manage all these atomic operations. Depending on which backend you use, you'll have a different database. And one thing that we've learned here as well is that you need a database, but you also need something to store your file, which usually depends on S3 compliant storage systems, and they're not all the same. So if you want to use your own, be careful of the guarantees that they give you, because they won't give you all the same guarantees, and your log might not behave in the same way. For POSIX, we can just rely on POSIX atomic operations. There's no central database. Everything happens with a file system. Something which is very important to notice is that this is a reliability feature. The fact that you can run multiple servers is not here for performance. It will impact performance, sometimes for the better. If you have more servers, you should be able to serve more QPS, but that was not the intent, which means that maybe you'll get more juice out of it if you have a beefier VM than having multiple ones.
So another log challenges is like sometimes read and writes, they could impact with each other. So read and writes, they are equally important. Another goal is to ensure read should be as cheap as possible. So with Tessera, reads don't go through the write server. And for AWS and GCP, the writes, they are staged in a different database. They go into Spanner, Aurora. And then for reads, they go to GCS or S3 directly. You don't even need to run a server yourself. And for POSIX, Tessera personality can only serve the write traffic if they want. It could be another server serving only the read APIs.
Another common challenge when running logs is, well, especially if you're CT, you want to run an append-only database, it accepts public submissions, you almost guarantee that somebody is going to abuse it. So you need to be very careful into what you put in your logs for multiple reasons. The first one is that you don't want to host data that you actually don't want to host. And then also just storage. You don't want to pay for things that you don't care about. Tessera's approach for this is that, well, Tessera is a library, so it does not filter the data for you. But because it's a library, you should embed the library in your server, and you should really filter the data in your own server. To figure out what data you need, you should really be careful about your climate model. So that's the model that is going to make it possible for you to really understand the transparency guarantees that you have around your ecosystem. And you should really have one before you design any new ecosystem. And from that, you can know exactly what you need to accept and only what you want to put in your log. So an example for TesseraCT, which is the CT server that works with Tessera, is that we will rate limit submissions that are too old, and also we only accept certificates that chain to a very specific set of routes. This is actually mandated by city policy, and it's a good thing. Too many requests. I think it's a problem whenever you run a service on the internet. People can just send requests, and you might become overloaded. And so you should really avoid accepting more requests than you can process. This is actually very interesting with like Andrew's talk earlier, who say that you should really be careful about not incorporating ACTs. You really want to incorporate all the ACTs that you give. And so we have different setups, we say, depending on the implementation. And AWS, GCP, and MySQL use a sequencing database where it's going to dump the data first when it receives it. And then an asynchronous process is going to put it in tiles. What I want to highlight here is that even though there is a database, and we've heard before that it might be tricky to have a central database when you run a CT log, this is very different than what was done before with CT logs, because in that database, we actually commit to the sequence number. We commit to where the data is going to be in the log, and we won't lose this data. It's there, and we know where it's going to be. Eventually, this asynchronous process is going to put things into tile, all the data into the log itself. And so Tessera gives you the ability to push back if you're running too far behind. So whenever it receives a request, it's going to see how many requests are in this sequencing table that haven't been dumped into the log yet. If it's okay, if you're below the threshold, then you can process the request. If it's not below the threshold, then you just reject the request and you cannot write to the log anymore, which is a good way to make sure that the log doesn't get too far behind. That's something that you can configure quite easily with your log. It's an Tessera option. There's a few of them, and they're all usable in the same way. But overloads could happen for different reasons as well. Somebody could just send the same data over and over and over again repeatedly. You could even read the log itself and feed the last entries back into the log. And so our goal was to prevent duplicate submissions from spamming the log. And it turns out that it's easier said than done. You would think, well, it's just easy. Look at what you have in your log. It's just a database. It's a simple key value lookup. It turns out that logs have a lot of data. And to make them more efficient, we use a lot of batch processes. Deduplication by nature is not something that we can easily batch because this is a one-to-one operation. For each leaf that you have a different key, so you need to do a lookup every time. And this is why we decided to make anti-spam, which is the name of this deduplication process, best effort and asynchronous. So what do we mean by that? It means that when Tessera runs, when Tessera server runs, there is an asynchronous process that's going to read the log and see what has been added to the log, and is going to populate this anti-spam database asynchronously. Same thing, you can configure it with the Tessera option. But that could fall behind as well. And if you fall too far behind, it means that you cannot deduplicate recent entries, and so you're back to the beginning. Somebody could just submit a lot of duplicate entries to your log. And so same thing here, we hold a watermark to see how up-to-date this anti-spam database is, and if it's falling too far behind, you can just reject submissions. So when we receive requests, we check where we are at. If it's good, we serve the answer. The index might come from this anti-spam database or not, because remember, this is a best effort deduplication. So it could be that anti-spam is running a few seconds behind, and as Andrew said this morning, this is okay. You can have some duplicate entries in your log. This is fine. However, if the anti-spam database is running too far behind, you can just say no to the client, tell them to come back later.
So another log common problem is clients needs to agree on the checkpoint. This is to prevent the log from presenting split view. As everyone said in the keynote this morning, logs without monitoring is useless. So what we need is witness here to countersign the checkpoints. So witness is, so what is witness? So the log would push the consistency proof to the witness, and then which is a very simple external process that checks the consistency and adds the signature to the checkpoint. And then for split view attack, it is a malicious logs can provide different views with verifiable signatures to different clients at the same time. So if you look at the diagram, log can provide checkpoint with hash ABC to client A, and then with another checkpoint DEF to client B and C. So with witness, these are external to the log. If you want to run one yourself, you can help the ecosystem, and there will be a witness breakout sections later today. And as I said, checkpoints can be countersigned by the witness. If you see the checkpoint now, there is only one checkpoint ABC that will serve to the client ABC. So with Tessera is quite simple. You just make use of this with witness function that you can provide a configuration. And there is also an option to fail open if the witness are available, but this will be fail close later since the integration with the witness network is new and is failing open for now.
And then yes, we run logs. We need to commit to data output in there, and it's hard. We need to make sure that the log commits to the data that are accepted before it returns anything to clients, which is very linked to this thing that Andrew mentioned, SCTs. So I think if there is one takeaway from this presentation is do not use SCTs. They are here for a reason in certificate transparency, and it's not easy to get rid of them, but they are bad. They give you weaker transparency guarantees. They're really hard to reason about. They lead to outages, so avoid using them. Even if you're designing a new system today that looks really like certificate transparency, try and see if you could get away without SCTs and maybe use inclusion proof directly. This is really important. I think we understand why it's there, but it's causing pain on a day-to-day basis. So nonetheless, how does Tessera handle this? So Tessera will only return things that it has committed to. So once it's returned an index, it means that this entry will be there at that index and it won't be anywhere else. And optionally, you can get stronger guarantees. Here again, depending on the backend implementation, it has a slightly different architecture. So for POSIX, everything is synchronous. Whenever Tessera returns an index, it means that not only the entry will be there at that index, but that it's already there, it's been integrated, the work is done. With the other implementation, as we said earlier, integration is asynchronous, which means that you get an index. It means that the log has committed to putting something there at that index, and the entry will eventually be present at that index a bit later. Usually that happens within a few seconds. Now, if you want to get stronger guarantees, you can wait for publication. So that means that you can wait for the entry to be available there and also to have a checkpoint that publishes it, that commits to it. It's very simple as well. You just enable the publication waiter, and it's as simple as a process in the background that's just going to wait. And once the checkpoint is available, it is there. So it's quite nice to use this feature when you run a log yourself, which means that if you return something to your client, you know that everything is there. The client could do that themselves as well, but you can do it server-side. And clients, regardless, should always check when they receive an answer from the log that the entry is indeed over there.
So human can make mistakes, and system outage could also result in data loss. So Tessera's approach is to have the persist data when the future is resolved and there is no multi-tenancy. So yeah, Tessera will continue to process the in-flight entries, like the entries with sequence number assigned, but not yet integrate into the logs. So no matter how much time how many times you restart the Tessera application, eventually it will process the rest of the entries and integrate into the log. And yeah, so there is, as you can see here, so we only got one log with dedicated servers, log storage, and the state. So hopefully that will help. Another common problem is you will need the visibility to know what's going on in the log. So with Tessera, you got the metrics from the open telemetry. So you can plug this graph in different dashboard. And you can plug this in any monitoring platform like GCP, AWS, and both, yeah, all of them will work natively. And on top of that, you can also see the trace here, like you can see different functions to drill down into each function to find out the latency issue. Yeah, for this one, looks like is waiting for the entry to be integrated to the log. So, any questions?
Thank you for the talk. One of the things that Andrew called out this morning was failure modes where databases took a very long time to restore after a log outage. It seems to me that that's, even though you are relying on a database, that's not going to be the case for you folks because your database is likely to be quite small, right? It's essentially limited to the size of the outstanding entries plus whatever the anti-spam database is, which you can toss. Is that?
This is correct, yes. The database is not here to hold a lot of data. It's just we need to have something that allows for atomic operations at a global scale, but really doesn't have a lot of data in there. Like it's like a few megabytes, maybe gigs at most, but it's not a lot.
Cool. And since I have the microphone, so I can just unilaterally ask another question. Your publication awaiter, like what sort of latency are we talking here? Like if you wanted to run on GCP, but you wanted synchronous inclusion, what sort of penalty does that cost you?
Order of seconds. We actually published a checkpoint, I think, every second, 400 milliseconds, something like that, less than 2 seconds, and then the waiter just like will see almost immediately. So it only adds a few seconds.
Yeah, so my question would be, if the publication awaiter is disabled, what would happen if the database were lost?
If you lose the database, then yeah, you will lose the entries that are going to be added to the log. Yeah, this is very true, but I think this is like, although you have different guarantees, if you use buckets, for instance, it could happen as well. If you lose your disks, then you've lost your data. So I think, like, what do you trust the more? Like, do you trust like more central database that has very few data? I don't know. Also depends on which backend you use. And I see that Al has another answer.
A thing to bear in mind is that Tessera is built for all transparency applications, which have sort of different requirements. And so I'm in agreement with you that for TesseraCT, you should run with the publication awaiter enabled, because then you get those durability requirements that you want. Other transparency ecosystems will have sort of different approaches. So I think Phil sort of mentioned this earlier. If you have a client that's waiting to log a thing and then it's going to build, say, an offline proof bundle, that integration awaiting is happening anyway, but just outside of the log.
Hi, thank you for all this amazing work. I'm curious about the checkpoints and the witness co-signatures on them, and how fast you expect those to come in, and like who's prompting who? What's the flow of events that makes those signatures happen?
Right, okay. So I'm not an expert in this one, so hopefully I won't say anything wrong. But with Tessera itself is going to push the consistency proofs to the witnesses, and the witnesses will reply as fast as possible. So this is what they push is quite lightweight, because it's just a checkpoint and a consistency proof. And then the witnesses are just waiting, and whenever they receive their request, they compute the consistency proof. If it's okay, they co-sign it, send it back to the log. The more witnesses we have, the better. And then we can decide how many co-signatures we want before we publish the checkpoint. If we want 5, 4, 3, I don't know, it depends. Also, as we said, you can decide whether you want to file open or close. Depending on your ecosystems, you might want to use different settings.
Okay, so is it the case then when you write out a checkpoint that will have however many witnesses you required in your configuration, and then that's done? We will never, if a witness gets back to me like a second later with a co-signature, I'm not going to bother to append the checkpoint or anything.
If the witness comes back and you still have not published a newer checkpoint, I don't know what will happen. Maybe Al knows. But the thing is, if you have published a new checkpoint already, then like the signature is too old anyway, so you cannot use it.
So Tessera is configured with a graph that needs to be satisfied. Where's the person that was asking? There you are. Yeah, Tessera is configured with a graph that needs to be satisfied for sort of it to have completed the witnessing step, which happens synchronously on publication of a checkpoint. Currently, we publish whatever we've got after some amount of time, but in the future that will flip the other way, and you'll need to meet the policy before you publish anything. And so Phil's right, you'll get as many signatures as you can within some window of time, and you'll publish or not. We don't try and tack on extra signatures sort of after we've already published, because that gets complicated when you're publishing things to like buckets where you can only write once per second, these sort of things. And then your other question, how long does it take? I mean, we don't really know, because there aren't that many witnesses kicking around at the minute. But if looking at sort of the profiles of what we're doing at the moment, we're talking, 100 milliseconds tops.
I'm thinking about how we want to use this in the SIGSUM log server, where we do replication at the application level to a different node. So then you would want to push the stuff into the local Tessera tiles, and then you would want to have them replicated to a secondary instance, and when they are reliably stored there, you sign new tree header or positive witnesses, etc. Do you have an easy answer to how to do that in a good way, or is that something we will have to figure out?
I think there are multiple ways of doing it. The best way to do that would just to use a storage system that handles replication itself, and you just offload that problem. You could do that if you use the S3 and MySQL implementation, if you have an S3 storage system that allows you to do this. Now, if you want to do that with the POSIX version, you could just use a file system that handles block replications, but you need to be careful if you do that to make sure that all the properties are guaranteed. Yeah, I would not recommend publishing a checkpoint until you know that everything has been replicated, and that's going to be served by different frontends, because then you could get inconsistencies.